Hello party people, how are we doing? So we have arrived at the 2015 free response scoring guidelines today. As you can see, I'm in a superbly good mood. And let's go over the scoring guidelines. Hopefully I can try to not make this a super long video. Okay, so here is my answer for the first question. I have socks with comparisons of the box plots. And for question 1, it says essentially correct E if you include the following 4 components: a correct comparison of center, a correct comparison of spread, a discussion of the outliers for corporation A, and the response is in context. Okay, so in context in this case I think is referring to corporation A and then dollars. So you need to make sure that those dollar signs are included to get credit for your context. And then I also put corporations here. Any kind of reference to corporation A, corporations, and then dollar signs on these numbers will give you context. I have my both comparisons is about 51 for my center, and then I said the IQR for corporation A is larger. I underline that because you know how the College Board loves the comparison words. Then B at about $9 versus $7 for B. Okay, you get a P for that if you include only 3 of the 4 components. So all of that stuff without context, let's say. And then I if you only have 2 of the 4 components or less. And it says you don't have to worry about shape because you can't really get a good idea of shape from this. So there are people who would say this was skewed, there are people who would say it's symmetric. Both are kind of justifiable, so you do not have to worry about shape. They're not grading that. Okay, now for part B, you need to identify a statistical measure for corporation A. So I chose IQR, and then I said you have a chance of earning a higher salary. Now notice I underlined that the College Board loves these comparison words, as I said. Higher salary because the IQR is higher, and there are 2 outliers. And so to get an E, you need to identify a statistical measure. I chose IQR, and I think you could choose outliers. And an explanation is provided for why that one's relevant. So I said you have a chance of earning a higher salary. And for B, you need to do the same thing. So I chose the lowest salary, so the minimum. And the lowest salaries are still higher than A, and then I referenced it, so there's less of a chance I will make a low salary. So I used a minimum, and then I used the comparison words for my explanation. Less of a chance I will make a low salary. Okay, so that's question 1. There are only 2 parts in that one, and so the scoring is, you can see it in the Google form, but it's EE, EP, and this is PI and II for 1, and then everything else is in the 2 range. Okay, question 2. You get an E if you state that the interval contains, because the interval contains 0.2, it does not provide convincing statistical evidence that the program is not working as intended. Since 0.2 is in the interval, there's not convincing evidence that the program is not working as intended because 0.2 is a possibility. You can get a P for that if you say that 0.2 is within the interval but don't draw a conclusion. Or you can also get a P if you messed up the endpoints of the interval but provide a correct conclusion with your interval, which is kind of nice of them. One nice thing. Okay, and then an I if you have no idea that you're supposed to use the confidence interval to check whether it's working correctly. Okay, section 2. You get an E if you conclude that there's not convincing statistical evidence that the computer program generates a discount with 0.2 and justifies the conclusion that there are other values than 0.2 in the interval. So I said no, you have values from 0.09 to 0.21, so there's not convincing statistical evidence that the program generates the discount probability of 0.2. So this is saying it can be 0.2, and this is saying it doesn't have to be 0.2, because there's other numbers in the interval. You get a P if you conclude that there's not convincing evidence but have incomplete reasoning. This one I thought was interesting. Incomplete reasoning is like stating that 0.2 is a plausible value, saying that it does not prove it. Something like that is incorrect reasoning. And then if you say there is evidence that it generates it at 0.2, then you get an I. It's just wrong. Okay. And then section 3 said you get an E if you give the correct value of 0.03 as the new margin of error by using the correct formula, or saying that quadrupling the sample size divides the margin of error from the original sample by 2. We've done that a few times lately even. So I have the correct formula and the answer, and I've calculated the interval again. You get a P if you use the correct formula or correct explanation but make an arithmetic mistake, as long as your arithmetic mistake is less than 0.06, because you should have a understanding that making a bigger sample size will give you a lower margin of error. You get a P if you did not calculate the margin of error but just simply say that quadrupling the sample size divides the margin of error by 2, or if you just put 0.03 without any work or saying anything. You get an I if you have like nothing that implies the square root of the sample size, and or if you have an answer that's anything bigger than 0.06, because clearly it needs to go down. Okay, last section for this, section 4, you get an E if you state there is convincing evidence that it's not working as intended, because based on the new margin of error, the interval does not contain 0.2. Okay, so I said since 0.2 is not in the interval, we have convincing statistical evidence that the program is not working as intended. So I've checked my new interval with my new margin of error. 0.2 is not in there anymore, so now we have convincing statistical evidence. You can get a P if your interval is incorrectly constructed, but you do a correct conclusion for your interval. You compute the interval correctly, and you make an argument that 0.20 is whether or not it's in the interval, but your conclusion is incorrect. You don't have a specific margin of error in B or C, but the response concludes that because the margin of error decreased, 0.2 is not in the interval. And you get an I, interestingly enough, if the interval is computed correctly, but no argument is made on whether or not 0.2 is in the interval, or anything else that doesn't satisfy that. Okay. Question 3. And feel free to pause me at any time. I know that you will. Because who can take this for very long? I'm kidding. I'm just in a really good mood. Okay. So, this one is so easy, it's hard. At least one ATM is really just this plus this plus this. So part A is scored, the probability is computed correctly with work shown. Just make sure that you guys are listing that out and putting the answer, correct answers given but no work shown as a P. And then you have the work, but you don't do the answer incorrectly or missing, that's also a P. Okay, this is interesting enough. You also get a P if you calculate less than 1, less than or equal to 1, or greater than 1. So if you completely read at least one incorrectly, like those words, you read them incorrectly and do this, this, or this, you still get a P. Again, kind of nice. Okay, part B, essentially correct if the expected value is computed correctly with work shown. So I have top times the bottom plus top times the bottom plus top times the bottom plus top times the bottom is 1.73 ATMs. P if you have the correct answer but no work, and P also if you have the work but the wrong answer or missing answer. Incorrect if it's none of that. Okay. Part C, you get an E if you have the probability computed correctly with work shown that includes correct values for both the numerator and the denominator. So what they're saying is you have 0.24 on the top, 0.85 on the bottom, and 0.282. If you have either the numerator or denominator correct but not the other one, you get a P, or if no work is shown, you get a P. Anything else is an I. Okay. Given that at least one ATM is working when the mall opens, would the expected value of the number of ATMs are working be less than, equal to, or greater than the expected value from part B? It would increase because the calculation in B reflects 0 ATMs working. So what okay, I kind of gave a vague answer here. I might even get a P. Let's see. Okay, you can get an E if you put greater than, with a reasonable explanation based on the fact that with x equals 0 eliminated, the probabilities for 1, 2, and 3 all increase. I don't know if I really did that. What I would rather say now that I'm looking back at it is for this to be a valid probability distribution, these numbers, these probabilities would all have to add to 1. And so with this gone, these numbers would have to be higher. I think that would be the best explanation. You can actually also say greater than and provide the conditional expected value computed correctly. I don't know if anyone did that. That would be really challenging. And so here is the answer for that. 2.04 machines with the work. If anyone did that, I am so proud. Like, so proud I can't even stand it. And you all can get a P if you have the correct answer with greater than with a weak explanation, such as yes, because 0 is eliminated. I think that might be what I did. And then an I if you provide the correct answer greater than. If you don't do greater than, so if you do anything other than greater than, you get an I. Or if you just say greater than with no explanation, you get an I. Okay. Man, I'm going to go back and add that. Or maybe I won't, because it's good teaching. Okay. Now, question 4. We're back in our wheelhouse here with hypothesis test. This is a 2-sample proportion test with Z, and we have to remember to pool. Anytime that you have a 2-sample proportion test for Z, you need to remember to pool. Okay, there are 4 steps. Yes. First step, essentially correct if you identify the correct parameters and both hypotheses are labeled, and state the correct relationship between the hypotheses. Okay, so I have A and P less than 0. This is less than. If you have these switched, if you have P in the front and A here, then you'd have greater than. That's okay. And 0.05. Okay. Notice I didn't define the parameters. I didn't have a lot of room. However, note this lovely comment. By defining either defining the parameters in context or simply using common parameter notation with subscripts clearly relevant to the context, such as P asp and P plaque, is sufficient. I did PA and PP. I think that would be okay. And, oh, it's placebo, aspirin and placebo. Okay, so you get an E if you have parameters identified, which I did with A and P, and the hypotheses labeled, and the correct either less than or greater than. So if it's in this order, you should have less than, and if it's in the opposite order, you should have greater than. Okay, step 2. Identifies the correct test procedure by name or by formula. So you don't actually have to state that it's a 2-sample P test for Z. Just having this formula with Z equals is sufficient. Notes that the use of random assignment satisfies the randomness condition. Okay, so I've got random assignment, yay. I should really have that twice. And citing that all 4 counts are larger than some standard criterion, such as 5 or 10 for your large counts condition. So I have successes, failures, all greater than or equal to 10. Okay. Step 2 is a P if you only have 2 of those 3 things correctly listed. Okay, this is something I really wanted to show you guys. For the randomness component, it is minimally acceptable to say random assignment check, but not acceptable to say random check or SRS check. This is not a random sample, so you have to be very specific that you say random assignment. And you also may use expected counts with the null hypothesis in place of observed counts in the normality. So I did 15, 85, 26, 474. You can actually attempt to calculate the expected counts there instead, but I'm sure you guys did the observed. Okay. Step 3 is a correct calculation of the test statistic and a p-value. Okay, so I have my test statistic at negative 1.75 and my p-value at 0.0397. You get a P if you have the correct Z but not the correct P. You get a P also if you have the wrong test statistic but then you make a p-value off of yours. So that's interesting. They have to sit and calculate your p-value off of your incorrect test statistic. You also get a P. This is for my people out there who don't show work. They just state the p-value because you did it on your calculator and you don't have any calculations shown. You get a P at least. Okay, step 4 is essentially correct if it's a correct conclusion in context with justification based on linkage to p-value and the given alpha equals 0.05. If you just write our usual conclusion, that counts for everything. So here's your relationship, here's what you're saying, and then you have your context. Okay, and the last one. Alrighty. Okay. Oh, look at my side. I think I got a P on this because first part A is scored as follows. So you need to have DA. The relationship is approximately linear, yes. Positive, yes. Moderate to strong association. You can say either moderate or strong, you just cannot say weak. And the response is given in context. Oh crap. I did not put any context in there. So you would say something like linear relationship between height and arm span. Moderate relationship between height and arm span. The side gets a P. Wah, wah. So sad. Okay. You get a P if you have 2 or 3 of the 4 components, and an I if you have 1 of the 4 correct. Okay. Part B is scored as follows. You need to choose the line in graph 2. You need to have an explanation for choosing graph 2. Square shapes are points on the line. Tall rectangle shapes are below the line. Short rectangle shapes are above the line. I said, oh, here I've got that. Y equals x, y is less than x, y is greater than x. Graph 2, because if a student was square body shape width, they would have the line y equals x, arm span height. Okay, you don't need to do the equations like this. You can just state the relationships. Square shapes are on the line, rectangle shapes are below the line, and tall rectangle shapes are below the line, short rectangle shapes are above the line. You have correct counting of 3, 4, and 5, and 3, 4, and 5 are in the table, so that is an E. If you only have 2 of 3 of the 4 components, that's a P, and only one of those 4 components is an I. Okay, just looking at this. To satisfy component 1 is sufficient to refer to the y equals x line without sufficient. Okay, that's good. That's good, because I did that. Okay. Part C. Correct formula for predicting arm span with 61 inserted for x. Okay. And then a correct value, 62.05 inches, and then units given as inches. Okay, so that's what you need to do there. 2 of those 3 components is a P, and then 1 of the 3 components is an I. Alright guys, I got it down to 21 minutes. We'll see how fast I can do the 2016. Miss you guys terribly. Hope you guys are well. Talk to you soon. Bye.